scalar and vector quantities. A scalar quantity is a physical quantity that has only magnitude or size. So an example is the mass of an object, the length of an object, density of an object, pressure, temperature, among others. So all these objects that we mentioned have only magnitude or size. Then a vector quantity is a physical quantity that has both magnitude and direction. It has both magnitude and direction. So an example is the weight of an object, displacement, then acceleration, among others. These are all vector quantities. Velocity is also part of a vector quantity. So this is our first question that we are going to solve on scalar and vector quantity. Distinguish between a scalar quantity and a vector quantity. So that is from WASSCE, November 2009. So it is very simple. We know a scalar quantity has magnitude only, while a vector quantity has both magnitude and direction. So that is the difference between the scalar and the vector quantity. Let's look at another one. Give one example each of a scalar quantity and a vector quantity. This is also from WASSCE, November 2009. So we mentioned some of them, but let's give some examples of scalar quantity. These are mass of an object, the volume of an object, work, energy, time, length, temperature, area, speed, then power. All these are examples of a scalar quantity. So we can see that all these are physical quantities that have size or magnitude. Then now let's turn to the vector quantity. Examples are, we have the weight of an object, we also have displacement of a particle, then momentum, then we also have force. Velocity is also a vector quantity. So all these examples are vector quantities. What is meant by mass of a body? This is from WASSCE, June 2011. The mass of a body is the amount or quantity of matter contained in the body. The amount or quantity of matter contained in the body. Now let's take some calculation questions. A room of area 12 meters by 14 meters has a height of 5 meters. If the density of air in the room is 1.32 kilogram per meter cube, calculate the area of air. Calculate the mass of air in the room. So this is from June 2011. We know that the density is related to mass and volume as follows. Density is equal to mass over volume. So we are asked to calculate the mass of air. So we can make mass the subject to get mass of air to be equal to density times volume. So we were given density of air in the room to be 1.32 kilogram per meter cube. So what we need to do now is to calculate for the volume. And we know that the volume is given by V is equal to the length times the breadth times the height. So we were given 12 by 14 by 5. So the volume will now be equal to 12 times 14 times 5. Now when we multiply this, we get a volume of the air to be equal to the volume of air in the room to be equal to 840 meter cube. 840 meter cube. Now we know the volume. We know that density rho is equal to 1.32 kilogram per meter cube. So this means that the mass of air in the room, is equal to 1.32 times 840, and this will be equal to 1108 kilogram. 1108 kilogram. A solid of mass 450 kg has a volume of 250 centimeter cube. Calculate the relative density of the solid. We were given density of water to be 1000 kilogram per meter cube. And this question is from WASSCE June 2012. So how do we solve this question? Recall that the relative density of solid is equal to density of solid over density of water. We know the density of water already, so what we need to get now is to get the value of the density of the solid. Then we plug in into this relation, and that will give us the relative density of solid, what we are trying to calculate. So let us calculate for the relative density of the solid. Let us calculate for the density of the solid. We know density is equal to mass over volume. So from the question, the mass is equal to 450 kg. And the volume is given as 250 centimeter cube, but we need to convert this volume to meter cube. So by doing that, we need to divide this by 10 exponent 6. 10 exponent 6. So we have the volume now to be equal to V is equal to 250 over 10 exponent 6 meter cube. Yeah, so we can rewrite this as 250 times 10 exponent negative 6. So that is the volume that we got after converting. Now the density is equal to 450 over the volume, which is 250 times 10 exponent times 10 exponent negative 6, and this will be equal to 1.8 times 10 exponent 6. 1.8 times 10 exponent 6. Now we got the density of the solid, so we just have to plug it into the formula to get 1.8 times 10 exponent 6 all over the density of solid, which is 1000 kilogram per meter cube, which is the same as 10 exponent 3. So the whole thing becomes 1.8 times 10 exponent 6. Let's send the 1000 to the numerator, and it becomes 10 exponent negative 3. So the whole thing simplifies to 1.8 times 10 exponent 3. So that is the relative density of the solid. So this is the correct answer.